higher gravitational effect. So in this paper, we have a connection between things that inspired the discovery of EVOs, things that support these observations, these observations, these assumptions, and hypothesis, and these observations that you see here. Now, when I was in Sochi, we took the Hutchison coral sample to Synthestech labs, and we did a test on that material. And it's here. So we put it on this XRF detector, and the purpose for me was testing soliton loop on coral Hutchison effect sample. Now, if we go and play this, let's play it. Yeah, so this video is all there. So now, what it was I found two candidate points, where you have one of these sort of crystals that seem to form in these craters, and these look like they could be candidate points for a soliton flux loop. And at this point, still, I'm thinking that these things are, you know, full loops, and they may be full loops, but, you know, anyway, we can see what we can see on the surface here. And again, we have a bigger one and a smaller one. And these are at the center point of what would be assumed to be these kind of, let's find that again. These, where have we got here? This would be kind of at the center point. So these are the two center points of these vortices. Now you can see that in this case, it's drawn them close together. Our observations that they have an effect over quite a range, but you can see that clearly they're clearly separated in these observations by Bostic, which are apparently observed by other people at the time. So what we did was we looked, and the assumption would be is that if the material was coming out of here and coming into here, like we observed in this is one impact, as far as I was concerned. This was one impact, and the material that came out of it was this, and this has got a high ratio of calcium, and it's not the same as the material around it. And in this case, this is a different, this is sort of a flux loop, and it's got this material that's come out of it, and it has a different elemental ratio. You know, if there are if this is part of the same loop, the assumption would be that that they would have the same elemental sort of ratios. And you know, we only tested, we just found one candidate loop, tested it, and it was really quite stunning because in fact I'll play this video through, but you can watch it separately. It's quite short.
Distribution of elements, and lo and behold, it's a pretty damn close match. Yes, there's a little bit more copper in the second sample.
Sorry, I just had a call here where I'm staying, so I had to pause that. You can go and have a look at the video, but essentially what it is here, those 2 points, the data is overlaid, and essentially every element that's in one point is in the other point, and there's just a itty-bitty bit of difference. When you actually look at the data on here, they are almost the same for each of the aluminium, iron, copper, zinc, sulfur. Really, they're almost exactly the same. So that was quite amazing. And then Chistolinov, that was with me, he suggested, other than these 2 points, why don't we have a look in a point that's somewhere between the two to see if it is different. And sure enough, there were other element concentrations, not elements that we had in these 2 points, and the concentrations were very different. So this was very, very satisfying. Now I'm going to go and get the sample because there's just something I wanted to discuss. So here is the sample, and it was on one of these faces where these 2 points were, and the central point that we tested. But the other interesting thing, and I'm waiting for the data to come back or for the test to be done at the Russian Academy of Sciences, but we cut off the end of this. And what is interesting about this is, well, apart from it seemed to find some very strange elements in there, like tantalum and well, all kinds of strange things, which probably aren't there, but it's just because that happens with LENR things. The effect doesn't seem to go through. Now, we need to look at the crystallography in here, and they'll polish that down and look at it in the way they can. But my assumption that it's going all the way through, it may actually be going all the way through, but when it comes to the impedance mismatch, the business actually starts to get a little bit strange. And it then does this transmutation and so forth on the material. So this is the coral sample, and you can see that it's not going all the way through. So perhaps when we are looking at these structures, maybe there is a full loop going on there, or maybe it is just from the surface out and down, or maybe it's just it gets affected by the loop in the direction that it's going. So it's going around like that, and it's twisting. Twisting. Anyway, so I want you guys to have a look at these various videos. Think about what he was saying about the neutron production being on the pinch of these things. There's a lot of information to get here, but really we have a multiply replicated experiment conducted in the 1950s and 60s that are claimed to be effectively producing the same thing as solar promontories, these magnetic flux loops. And here it's published in fluid dynamics paper. You know, this is fluid dynamics, this is fluid dynamics, this is fluid dynamics. So could it be that something is produced which is actually some sort of torsion field or some sort of spinning vacuum that's actually disrupting the material here, because this is not within the main part of the heater. This is just the bend, and then the coil starts from there onwards. You can see it in the video here. You can see, if I go back, you can see that this is here. There's the main part of the heater. The hottest part will be somewhere in there. So this is outside of the heater. The tip of the reactor came to somewhere about here, inside there. So it's nothing to do with being in contact with any chemicals. It's otherwise clean, and no one's been able to explain it, but it looks like something happened within that, that maybe there was some thing going around here that's causing this movement of material. That's enhancing the B field that's coming through here. And along with the gravity, it's causing something to come out here, which is affecting the quartz, not by temperature, but by disrupting the electrons, as Shoulders said to Morrow B. King. It's actually disrupting the electron bonds and able to move the matter. And that is potentially what we're seeing here. And potentially these flux loops can join together, just like they do on solar promontories. I get that word wrong, but anyway, it's coming out here, and they're kind of joining at the top here. And you're seeing the same thing here. We know when you push a plate through water, it's going to be there all the time, but they get bigger and move out apart, but they keep the sort of wormhole, this half soliton. And maybe there really is a half soliton. Maybe all of these are actually half solitons, or they're full solitons. I would suggest that they are full solitons from the point of view that if you're going to have material in them, unless it's teleporting from one side to the other of the half soliton, it has to go through the material. And when it's going through the material, it basically has to have no dimension. So it's like a wormhole. It's literally spinning around in the material. And when the confining field breaks down, the material just spits out, and it comes out as whatever element it was stably structured as within that particular loop. And as I've said before, when when these are oriented with the surface, like in the this Hutchison sample again, down at this end, you have these loops. And so maybe you have the thing going around here, but there's a loop going around here, and they go like that. The two circles overlapping. They have these circles of material, and it's like light elements on the outside, heavy elements in the core. So it's almost a fractal structure in its own right. So it's been an interesting journey this year, and this really was one of the hugest questions for me. This is on LION 2, and this structure on LION 1. And similar structures observed on Hutchison sample from 2007. And having this mystery here really piqued my interest. And to summarize, we have this paper, which was funded by the two bodies under which it was claimed to be funded by the Air Force. This is funded by the Air Force. This fits the time period. And the bodies that funded it are the bodies under which the classification for this was made. And it is the inspiring work for Kenneth Shoulders, from which he discovered EVOs. So thank you very much for your time. Sorry for the shaking video. If you feel this work is useful, please consider making a donation. It really helps. And check out the other links in the bottom of the video. Thank you.